So in today's lesson, we're going to learn how to use the unit circle that we built yesterday. So first of all, I probably haven't mentioned this before, but you always want to put your last name and your first name on every time you see that on the note page. That way I can verify that you are the one doing your notes when I actually collect them. Also remember, between the essential question and the summary, you need 2 comments or questions for our focus note taking. So go ahead and write down the essential question. I'm going to end the I can statement. I'm going to probably break this into 4 smaller videos, so that way it's not quite as much at one time. So our essential question is, what is the relationship of the angles in a 30, 60, 90 and a 45, 45, 90 right triangle and the angle measures in the unit circle? And then by the end of this, you're going to be able to use the unit circle to find the exact value of an angle based on a reference triangle. Okay. So you can pause that and write that down if you'd like. So the next thing we're going to talk about is, what on earth is this thing that we're calling the unit circle? So it's basically that. It's a circle that is one length, one long. So I'm going to draw myself a nice little circle. And I know the radius length is 1 unit. To relate to what's going on here, and they're talking about this is an equation of a circle. So basically what's happening here is we draw a ray and we can get a triangle put in there, just like the triangles we put on our unit circle build. The reference angle in here is this angle right there. And then we know that that's the radius, so that's R. Since this is in the X direction, I'm going to call that X, and that's in the Y direction, I'm going to call that Y. And basically, from that triangle, if we're going to use that reference angle, we can now find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So let's just do that. So the sine of this particular triangle would be the opposite Y over the hypotenuse R, meaning the cosecant is R over Y. The cosine of this particular triangle would be the adjacent X over the hypotenuse R, and the secant would be the reciprocal R over X. The tangent in that particular triangle would be Y opposite over X adjacent, and the cotangent would be the reciprocal. So we're going to talk about these trig identities. So there's a few things that make our life easier, okay? We've already talked about reciprocals, okay? We know that the cosecant is the reciprocal of sine. So if we had sine, or if we have the cosecant of x, we know that that's the same as saying 1 over sine x. Because if sine looks like that, its reciprocal is 1 over that. Excuse me. That means that the secant is 1 over cosine x. And I missed putting x's in there. The tangent and the cotangent, the tangent is 1 over cotangent, and the cotangent is 1 over tangent, but I don't want reciprocal identities there. I want to be able to put things in terms of sine and cosine because my unit circle is going to be set up for that. So my tangent is the sine of x divided by the cosine of x. The cotangent is the reciprocal of that, the cosine of x divided by the sine of x.